Hey everyone, so today we're going to talk about long division by a binomial or trinomial, as well as complex fractions. So the first thing I want to start out with talking about long division is that it's pretty much similar to the process you learned way back when you did long division in elementary school. So let's try this one out. So the first thing you do, you think, can 4 go into 2? No. Can 4 go into 22? Yes, it goes in 5 times. Now remember, the next step is you multiply 5 times 4, you get 20, and then think about that next step, you subtract. 22 minus 20 is 2. Next step, you bring down the 9, then you think 4 goes into 29, how many times? That would be 7. 7 times 4 is 28. We subtract again, and we're left with 1. So some of you might remember how to do like the decimal and you keep going. We're actually just going to do kind of a fractional remainder. So remember, this is called the remainder, and you would do 1 divided by 4, or 57 and 1/4. You would have gotten 0.25 for your decimal. So that's kind of the same process I want you guys to think about as we try out these problems here. The biggest things is make sure it's written in descending order or standard form. And then if there's any terms missing, make sure we fill it in with a 0, kind of as a placeholder. So I'll show you that in this first one here. Okay, so we're dividing by x plus 3. Remember, when we're dividing by a binomial or trinomial, that's where this is going to be special. Okay, so we have x plus 3, big division bar here, x to the 4th, now notice what's missing, plus 0x cubed plus 3x squared plus x plus 4. So every time we talk about these problems, make sure you have a 4th, well, whatever the highest power is, that power, the next. So this is 4, 3, 2, 1, and then a 0th power here would be the last one. So if the one is missing, one or more is missing, fill that in. Okay, now your next step is kind of similar to what we were doing with the numbers, is you want x to match x to the 4th, or you want to think, what do I multiply x by to get an x to the 4th right here? Okay, you would have to multiply by x to the 3rd. And why did I pick that? Well, I'm going to multiply x to the 3rd to each of these. That would be x to the 4th plus 3x to the 3rd. And again, think of that process in long division. The next thing you're going to do, okay, I'm going to use a different color here, is you're going to subtract this entire thing. Okay, so typically what you'll see me do, instead of with parentheses, I'll go change the sign, because we're subtracting each piece. Okay, so x to the 4th minus x to the 4th cancels. If your first term doesn't cancel, you should start over, because that means you did something wrong. Then I have 0 minus 3, which is negative 3x cubed. So that's fine with us. And remember, that next step that we usually do, we get something and then we say, let's bring down the next term. Okay, so now what you want to think about, again, your goal is this. You want to get exactly matching. You want to get a negative 3x cubed. So you want to think about what's something I can multiply x by? X times what is negative 3x cubed? That would be negative 3x squared. So I'll erase these orange marks here. I'm going to take negative 3x squared, multiply it by my two terms. So that would give me negative 3x cubed. And then I've got minus 9x squared. Again, I'm going to do a big subtraction problem here. I pick a new color just for organization, and I'm going to go through and subtract both pieces. Now notice they were both negative, so now I just changed both signs. They both actually became positive, right? Because technically I'm subtracting the whole parentheses. Okay, so change both signs, cancels. That needs to cancel or this problem will not work. And I get 3 plus 9 is 12. X squared. Okay, keep going here. We bring down plus x. And it's that same idea here, guys. How do I match 12x squared? What do I multiply x by to get 12x squared? I'm going to multiply by positive 12x. When I multiply 12x in, I get 12x squared plus 36x. Okay, and from there, what I'm doing, remember, you cannot forget this step. This is where everyone forgets. You need to subtract both terms, right? Or change both signs. cancels. I get negative 35x. We're getting there, guys. Plus 4. And your last couple steps here is, we're almost there because really we can't divide too much more in. Your last steps here, negative 35x. So again, you want it to exactly match negative 35x. So you're thinking, what can I multiply x by to be negative 35x? I'd multiply by negative 35. Negative 35 times x. Negative 35 times 3 is negative 105. Okay, we draw our little subtraction problem. We're going to be subtracting both of these. Minus negative 35 minus negative 105 cancels. I get 109. Okay, at this point, 109 times what is x? I mean, we don't have anything. This is our remainder. And remember, we take that remainder and we're going to divide it by our divisor, or x plus 3. So very final answer there. I'll write in purple over here. X cubed minus 3x squared plus 12x minus 35 plus 109 over x plus 3. So you can see there's a reason we only have a couple of these examples, because they take up a lot of time and they're pretty heavy in terms of how to get the algebra here. Now, the nice thing is the process is the same every time. My issue is if you forget one negative, it kind of ruins the rest of your system. So just be careful here. Okay, we're going to try one more here. We're actually going to try this one below, this third one here. So I have x squared plus 1, and I have x cubed plus 3x squared plus x minus 3. Okay, so let's set this up. X squared plus 0x plus 1. Remember, if I start with a second power, I need a first power and a 0th power. Every power needs to happen in between. And I'm doing my division here. X cubed plus 3x squared plus 1x minus 3. And I check. 3, 2, 1, 0. So I've got all my powers. I didn't have to fill anything in there. Okay, so let's finish this up here. Try it out. X squared times what? Again, think your goal is I want this to say exactly x cubed. So I'm going to just multiply here by x, because if I do x times x squared, I get x cubed. X times 0x gets me 0x squared. And 1 times x gets me 1x. Okay, and again, take a new color here. We're going to go through and subtract, 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 subtract. Cancels, that needs to cancel. Again, if it doesn't cancel, that means you did something wrong. 3x squared, and then 1x minus x would just be 0x, and I just put it there as a placeholder. And now I've got to bring down negative 3. So this is actually not going to be that many steps because really we've already brought down our last term. Okay, so let's think what multiplies to 3x squared, and what times x squared is 3x squared? That would just be 3. So I'm going to do plus 3. That would give me 3x squared plus 0x plus 3. Okay, now be careful. You might be tempted to think there's no remainder, but I want you to be aware here. Negative, negative, negative. This would be cancels. 0 minus 0 cancels. This, though, gives you a negative 6. So just be careful. Some people think those are going to cancel out. And so we get minus 6 over x squared plus 1. Remember, whatever you divided by. So x plus 3 minus 6 over x squared plus 1. And you don't need the 0x in your final answer. That's just as a placeholder for division. Okay, so again, we'll try that second one in class. So hold on to that. Rewind if you need any more help or want to see that process over again. Okay, the last thing we're going to do is complex fractions. Complex fractions basically mean we have fraction over fraction. So notice we have like kind of quadruple fraction looks here. Okay, so what we're going to end up doing, we are going to take the problem, and the directions are right here. We're going to find the least common denominator of all of the baby denominators. What I mean by that is these guys, baby denominators, little denominators. So we're going to multiply it by that and simplify. So let's find the least common denominator first. Okay, least common denominator, you have a, b, and ab. Well, least common denominator would be a times b. Okay, so what you're going to do, we're going to multiply that entire numerator by AB, over 1 technically. We're going to multiply the entire denominator by AB. So really, we're multiplying this whole thing by 1, right? AB over AB, but we're going to distribute this AB to the top and this AB to the bottom. Okay, again, it's really AB over 1 and AB over 1, so we're just going to multiply those numerators and see what cancels out. Okay, so AB, I'll trace here in purple. AB times 1 over A would give me AB over A. You could simplify right now if you want. Plus AB over B divided by AB over AB. Okay, so the whole point of this, and you can definitely simplify quicker than I am, is that you can cancel out all of these little denominators. So this should be B plus A divided by 1, which is just B plus A. So that whole quadruple fraction becomes B plus A. Okay, so let's try one more of those, see how we're feeling about it. Okay, so take a look at the next one here. I've got x minus 1. So again, I'm looking at all the denominators. I see 1, I see an x minus 1, 1, and an x plus 1. So my least common denominator here is going to be x minus 1 and x plus 1. Take all my baby denominators and decide what is something they share. What's their least common denominator? Okay, I take the entire top, I multiply by x minus 1, x plus 1, divided by, take the entire bottom, multiply by x minus 1, x plus 1. And again, it's technically like over 1, if you want to think of it that way. So I'm just distributing these to the numerator. Okay, and let's see what we get here. All right, so I'll do this in green here. So the first one, we get x minus 1, x plus 1 over 1. So I'm just going to leave that. Okay, the second one here, the x minus 1s, notice this, guys. I'm going to try to cancel a little quicker here. X minus 1 and x minus 1 are going to cancel. So I just get plus x plus 1 here. Okay, how about the next piece? Well, the next piece I'm going to get, I'll kind of erase some of my work here. Oops. Maybe not. The next piece here, if I go over here and multiply to 1, nothing's going to cancel. So I get x minus 1, x plus 1. And the next piece, let's see, the x plus 1s will cancel from that numerator denominator. So I'll just get plus x minus 1. Okay, so we did all our distributing. We're down to just a regular fraction, but you guys cannot fall for this right here. Can I cancel these out? No. I hope you're saying no, because I'm still adding. These are not factored. I can only cancel things when I have parentheses multiplied together. And nothing is added still. So let's multiply this out. X minus 1 times x plus 1 is x squared minus 1, right? X squared plus 1x minus 1x minus 1. We get that difference of squares. So the top, I get this, sorry about that, plus x plus 1 divided by, this again is x squared minus 1 plus x minus 1. So let's see what we get here. That gives us x squared plus x divided by x squared plus x minus 2. Okay, and let's see if we can do anything else here. Okay, oh no, I thought I messed up. Okay, wait, let's go back. Right here, total fluke here. My bad. This should have been a negative. I'll do it in red here. I'm sorry about that. I knew this wasn't how it turned out. Whoops, classic mistake. Distribute that. How about minus x plus 1? Okay, so in the denominator now I have x squared minus x, and the 1's cancel. Again, I'm not crossing out here, but I do notice this is x times x plus 1 over x times x minus 1. If I factor both of these, take out those GCFs, x's cancel, and my very final answer is x plus 1 divided by x minus 1. Nothing else we can cancel there. Okay, phew, messed that one up a little bit. Sorry about that. But I think we're set to go now. So again, as you look at these problems, what you're doing, you're multiplying by that least common denominator of all the baby denominators. You're simplifying the fraction, okay, whether you write it out like this or you can jump to the part where stuff is canceling. You simplify, as always, you try to factor, see if anything cancels, and you're done. So again, this is it for this unit here. We're gonna finish up one more long division and one more complex fraction in class. So please bring in any questions, and thanks for watching.